Kia ora koutou. This video is for Year 12 students who are coming to today's slightly early session to do some Level 2 algebra skills. I thought I've got time this week to do a video to go with the questions I'm going to give out, because I know for lots of you, you haven't really started algebra at Level 2 level. So the more you see these questions, the easier they're going to feel. If this is still much too fast for you, I want you to go and watch one of the separate, I'll just spell one correctly, I've got it wrong there. So go and watch one of the separate, slower Level 2 videos that I've done. For example, I've done videos on completing the square and I've done videos on grouping. So if you're seeing those ideas for the first time, you'll be able to follow them, but you need to get really comfortable with them. And the way to do that is to do lots of questions. So in this video, there's going to be lots of mixed up stuff, and we're working at around merit level, Level 2 straight away. Okay, let's look at this first one. We're going to solve this quadratic here, and we're going to do that in two different ways. The first way is using a Level 1 method called grouping, and the second way is using the quadratic formula, which will be brand new to lots of you. This one here is also going to use the quadratic formula. This is going to use an idea linked to the quadratic formula. And then these two here are just different ways to factorize. Okay, so let's start off with question 1. We've got 12x squared minus 5x equals 2. As usual with a quadratic, we want to make it equal 0. So we'll subtract 2 from both sides. And now we look at it and we see that we've got a prime number here, but we don't have a prime here. So some of you will be able to do guess and check on this if your intuition for factorizing is really good. Assuming that it's still developing, I'm instead going to use the grouping method, right? So this is where we have to decide how to split that minus 5x term up. And the way I do it is like this. I've got the two numbers here, so we'll call this A, this is B, and this is C. C is the -2, those coefficients. And this is sometimes called the AC method, because I want to find two numbers that times to give me -24. And those same two numbers have got to add together to give me that middle term of -5. So if you think about factors of 24, we're looking for a gap of 5, and we're going to find that with some combo of 3 and 8. So we whack in 3 and 8, and then we decide which one is going to be the negative and which one's going to be the positive, right? Because if they're timesing to give me a negative, one will be negative, one will be positive. So if we make that -8 and that -8, everything works out. What that's telling me to do is to break down that minus 5x as follows. So I get 12x squared, doesn't matter which order you go, minus 80x plus 3x minus 2 equals 0. Now then we put a little box around here and we do what we call two-step factorizing. So we factorize that first box and we get 4x into 3x, that's a squared there, 3x minus 2 plus, and then look here, we've got that sitting there, we've got one lot of 3x minus 2 is equal to 0. Now we can factorize the whole expression and we get 4x plus 1 coming from here times 3x minus 2 equals 0. That gives me my two solutions. X is equal to -1/4 or x is equal to 2/3. So that's all good. But what I want to show you now is this thing called the quadratic formula that some of you will already know, some of you will hate it, and some of you will love it. So -b plus or minus b squared minus 4ac over 2a. Now the most important bit in this formula that comes up over and over in Level 2 and scholarship is this thing in here, which is called the discriminant. And this is going to tell me how many solutions to an equation I've got. Really quickly, if I've got no solutions to the equation, that means that I can't take a square root of this at the moment because it's a negative number. So we say that this has got a discriminant that is negative. So the discriminant is that thing under the square root, b squared minus 4ac. If instead we've got what we often have, where we've got two roots, that means that I could successfully square root that number. So b squared minus 4ac is going to be positive for two solutions. And lastly, if I've got one solution just touching here, that means that when I square rooted this, I got 0. So that my plus or minus here, oops, something's disappeared, my plus or minus has not changed anything. So this discriminant thing comes in really handy. But in this question, all I wanted to do was just to show you how we do a simple quadratic formula problem. So this is actually a low achieved question from an old Level 2 paper. So A in this one, A is 12, B is -5, and C is -2. So we shove all those values in, and we get x is equal to -5, so 5 plus or minus the square root of this squared, so 25 minus 4 times 12 times -2. Be really careful with your negative numbers. Divided by 2 lots of A, divided by 24. So that gives me x is equal to 5 plus or minus, well, this is 25 plus 96, so that's the square root of 121 divided by 24. So I can either get x is equal to 5 plus 11 over 24, or x is equal to 5 take away 11 over 24. This gives me 16 over 24, which is 2/3, and this one gives me -6 over 24, which is -1/4. And obviously that matches up to what we got before. So that's all good. Right, on to question 2. Question 2 doesn't look like a quadratic, but it is a quadratic. And if you stick around and keep going with Scholarship Calc, you're going to see all the time that we try and find ways to see how things are quadratics when they don't start out looking like that. The first thing I'm going to do here is to multiply everything through by x so that I don't have any fractions. So I have x squared plus x minus 3 equals 0. Now I look at that and I can't factorize. I also don't want to do completing the square on it, even though I love it, because this is not an even number, it's plus 1x. So I'm going to get on with it here and I'm going to use the quadratic formula. We get x is equal to -b, so -1 plus or minus the square root of 1 squared minus 4 times 1 here times -3 here, divided by 2 times 1, which is -1 plus or minus the square root of 1 plus 12, root 13, divided by 2. That equals -1/2 plus or minus 1/2 times the square root of 13. Now, I didn't have my calculator handy. That is a beautiful answer because that's an exact answer. But I think in NCEA, what they want you to do is go and chuck that into your calculator. And the calculator can do the solving for you, but that won't give you any understanding and it won't help you when you start doing harder problems. So we go to our graphics calculator and we get the number. Right, let's have a look at number 3. So there are 2 ways to do this one. Does the graph of this cut the x-axis? And I've just very quickly told you about this thing called the discriminant. Is it like this, is it like this, or is it like this? So the first and very fast way to do this is to use the discriminant. And the other way to do it is to look at it graphically by completing the square on it. Okay, so if we've got 2x squared minus 2x plus 5, if that's y, we can complete the square on it as follows. We get 2 times x squared minus x plus 5. So what we're doing here is we're putting our parabola into vertex form, which all of you will be pretty comfortable with from last year, hopefully. So here, we're going to halve this. We get x minus 1/2 squared. Now we've added in -1/2 squared, which is 1/4, so we have to take it out. That's the way that I do completing the square. You might have learned a slightly different way at school, but it all comes out down to the same thing. So what I've got here shows me that this is never going to touch the x-axis because this bit here, this has always got to be 0 or bigger because it's a square number. And then we're going to add on 4 3/4. So this thing here, y, is always greater than or equal to 4 3/4. So never touches x-axis. So y does not equal 0. So that was good. And the nice thing about that is that you can draw a good graph. So there's your half there. Somewhere up here is the vertex. That vertex is going to be at 4 3/4 or 19 over 4. Okay, so it's very easy to see visually, but it was a bit of work. So instead what we can now do is we can use the discriminant and we can say y is equal to 2x squared minus 2x plus 5. A is 2, B is -2, C is 5. B squared minus 4AC is equal to -2 squared minus 4 times 2 times 5, which works out to be 4 take away 40, negative 36, which is less than 0. So there are no real solutions. Graph doesn't cut axis. Graph doesn't, what were we asked to say? The graph, look at the wording in the question. Does the graph cut the x-axis? No, it doesn't. Doesn't cut x-axis. So there we go, that's that one done. Now, on to the next question, which is question 4, which looks bad, but it's just a bit of expanding, collecting up like terms, and then looking at what we're asked to do in the question. So just getting rid of some of this mess here. Let's just start by expanding all of this. So this is equal to 3x squared plus xy. So I'm going in this order here. Minus 36xy minus 12y squared. Keep your brackets there, minus the next one. 2x squared plus xy minus 32xy minus 16y squared. And you can see we've got a whole bunch of like terms. So as I expand, I'm going to do, as I do the next line, I'm going to do a bit of like term cleanup. I get 3x squared minus 35xy minus 12y squared. Now, minus 2x squared. Here I've got minus 31xy, but I'm multiplying by this, so I get plus 31xy plus 16y squared. All right, now look what we're asked to do. We have to try and get this into this form here. This form here, where's my pen gone? There. So we just have to keep going on the cleanup first. We're still collecting like terms, and hopefully something nice will happen. We get 1x squared, so x squared. Here we get minus 35xy plus 31, so minus 4xy. And here we get plus 4y squared. And now you can see that I've got a perfect square. Usually your perfect squares until now have looked like this, x squared minus 8x plus 16, right? And we've had x minus 4 all squared. But this time we're going to have x times x, and here we're going to have a 2y and a 2y, and if we put minus there and minus there, then we're done. So this is what the question's asking us to do. That gives me equals x minus 2y squared. And we were asked to put it into a plus b squared form, so we could say a is equal to x and b is equal to negative 2y. Right? Good. Okay, what's left? I've got 2 minutes until the video runs out, and the dog is starting to do bad things, so I need to get going. The next question is a nice little one on two-step factorization, which is one of my favourite things that comes up in the hard problems. And it's something that I think Year 12s often kind of either forget about or avoid. It's a really good method if you're stuck and you have to factorise. So we're just asked to factorise this, and it looks hideous if you're not used to this method. So I always start these by just putting a box around the first two terms, and then I'm going to put a box around the second two terms like that. And we hope that something's going to fall out. So just focus on this and factorise those two terms. Well, look at the numbers first. We've got 2, we've got a b here, but no b here. And then we've got an x here and an x here. So 2x is the common factor, and we have to times it by 2b to match that up, plus 2x times y. Do the same again, and we hope something's going to fall out, right? We're going to have a minus here. We've got 6 and 3, so the common factor is 3. We've got a here and a here. Take out the a as a factor. Now, I have to times by what? Well, I've got to have a 2b, and here I've got to have a y, but I've got a minus here and a minus here, so it has to be a plus y. So look at that. I've got this beautiful repeated factor, and so now I can factorise and say that this is equal to 2b plus y, 2x lots of it here, take away 3a lots of it here. Now, if you don't feel comfortable about that, go back to that and expand it out. But that is that question done. Now, I've only got 30 seconds left, and I'm going to take much longer than that on this question because there are 3 ways to do it. So I'm going to stop here for now, That's the first 5. I'm going to take the dog for a walk, and if I've got time, I'll do question 6 when I get home. Thanks for watching. Please let me know if this is any use. Otherwise, I'm not going to do too many of them.